Imagine, if you will, a world without borders, a world not of concrete and steel, but of endless savannas, vast primordial forests, and glaciers so colossal they sculpt entire continents. This is the world of our deep past, a stage set not for thousands of years, but for hundreds of thousands. Upon this stage, our ancestors walked not as kings of the planet, but as one species among many, struggling, adapting, and persevering in the face of an indifferent and often brutal nature. Now, consider a number, a figure so staggering it defies easy comprehension. Approximately 900,000 years ago, something cataclysmic happened to the ancient human population. The fossil record, the genetic clues buried deep within our very DNA, and the slow, patient work of paleoclimatologists all point to a single, profound event. The human race teetered on the very brink of extinction. The evidence suggests that our entire species was reduced to a mere 1,280 breeding individuals. Let us sit with that number for a moment. 1,280. A number small enough to fit in a single large lecture hall. From a population that may have been scattered across continents in the tens of thousands, humanity was crushed down to a group small enough to be considered endangered by modern standards. For over 100,000 years, this tiny band of survivors clung to existence, their lives, their loves, their struggles, and their stories now lost to the deep time of prehistory. This period is what scientists now call the population bottleneck. The story we are about to unravel is perhaps the greatest detective story in human history. It is a mystery that spans millennia, a puzzle whose pieces are fragments of stone, isotopes in ancient ice cores, and the silent, whispering letters of our genetic code. The question, why did 99% of early humans vanish, is not just a query about demography. It is a profound exploration into our own resilience. It forces us to confront the fragility of our existence and the incredible thread of chance that connects every single human alive today back to that small, resilient group of survivors. For a long time, the narrative of human evolution was seen as a relatively linear march of progress. A stooped ape gradually stood upright, grew a larger brain, discovered tools, and conquered the world. But this simplified story obscures a far more dramatic and terrifying truth. Our path was not a steady climb. It was a roller coaster of adaptation, disaster, and breathtaking luck. We were not always the inevitable masters of the globe. There were moments, and this was the most severe of them all, when the flame of human consciousness flickered so faintly that a strong gust of wind might have snuffed it out forever. The world, had it turned out just slightly differently, could have become a planet without USA world, where the symphony of human language, art, and civilization never played a single note. Unraveling this mystery requires us to become time travelers. We must journey back nearly 1 million years to meet our ancestors, not as caricatures, but as real people facing unimaginable challenges. We will explore the world as it was, a planet in the grip of immense climatic upheaval. We will delve into the cutting-edge science of genomics, which allows us to read this ancient story in our genes. We will examine the geological and ice core records that act as a planetary diary, recording the environmental conditions that pushed humanity to the edge. And we will sift through the archaeological evidence, the stone tools, the scarce fossilized remains that offer silent testimony to their struggle. This is not a tale of doom, but ultimately one of hope and incredible tenacity. It is the story of the ultimate underdogs. The fact that you and I are here today, able to ponder this very question, is proof that they succeeded. Their survival against impossible odds is our shared inheritance. The echo of their near extinction is written in our DNA, a permanent reminder of how close we came to being nothing more than a fossil footnote in Earth's history. So, prepare to embark on a journey into the deepest reaches of our past. We will investigate the prime suspects: dramatic climate change, volcanic winters, resource competition, and even the possibility of a catastrophic event from beyond our world. We will meet the species involved, Homo heidelbergensis, the likely ancestor who faced this great calamity, and trace the paths of their children who would eventually become Neanderthals, Denisovans, and modern Homo sapiens. We will navigate the Middle Pleistocene, the epoch of this great bottleneck, a time whose mysteries are only now beginning to yield to scientific inquiry. This is the story of the generation that almost wasn't, and of the few who held on, ensuring that the human story would continue. This is the search for the moment we almost vanished. Before we can understand the catastrophe that nearly erased humanity, we must first meet the people who faced it. They were not us, not exactly, but they were undeniably, profoundly human. To look upon one of them would be to see a familiar intelligence burning behind eyes set in a more robust, archaic face. This was the age of Homo heidelbergensis, a species that many paleoanthropologists believe stands at the very heart of the human family tree, the last common ancestor of both the Neanderthals in Eurasia and our own species Homo sapiens in Africa. The name heidelbergensis comes from the discovery of a massive, ancient jawbone in a sandpit near Heidelberg, Germany, in 1907. But this species was far from a European novelty. Their fossils have been found from the highlands of Ethiopia to the terraces of England, from the plains of Spain to the caves of South Africa. They were the first truly widespread humans, a testament to their remarkable adaptability and ingenuity. They thrived for hundreds of thousands of years, from about 700,000 to perhaps 200,000 years ago, a reign of 500,000 years that makes all of recorded human history seem like a brief footnote. So, who were they? If we could observe a band of Homo heidelbergensis, what would we see? Physically, they were formidable. They were tall, with some individuals reaching over 5 feet 9 inches, and powerfully built, with thick bones and strong muscle attachments. Their skulls were long and low, with a prominent brow ridge and a large face, but housed a brain that was rapidly expanding. Their cranial capacity, at around 1200 to 1400 cubic centimeters, overlapped significantly with that of modern humans. This was not a creature of brute instinct. This was a thinker, a planner, a social being of considerable complexity. Their world was one of stone and wood, of fire and community. The archaeological record they left behind is dominated by stone tools, but these were not the simple, flaked cobbles of their ancestors. Heidelbergensis were master craftsmen of the Herculean tradition. Their signature tool was the hand axe, a teardrop-shaped, bifacially flaked masterpiece of stone that represented a quantum leap in cognitive ability. Creating a hand axe was not a random act of chipping. It required an internal mental template. The maker had to see the final product inside the raw lump of flint or quartzite. It demanded advanced planning, an understanding of geometry and fracture mechanics, and a skillful, controlled application of force. These were not mere cutting tools. They were multi-purpose instruments: butchers, knives, diggers, projectiles, and perhaps even symbols of skill and status. The symmetry and refinement found on some hand axes go far beyond mere utility. They hint at an early nascent sense of aesthetics, a desire to create something that was not just functional, but also right. But their most revolutionary invention was not made of stone, but of flame. While earlier hominins may have harnessed natural fire, Homo heidelbergensis appears to be the first to have learned to control it consistently, to tend it, and perhaps even to ignite it. This control of fire was a technological revolution on par with the invention of agriculture or the internet. It provided warmth, allowing them to survive in colder, more northern climates previously inaccessible to a tropical primate. It offered protection, flickering light and crackling sound to keep the formidable predators of the Pleistocene cave lions, saber-toothed cats, giant hyenas at bay. It became a social focal point, a hearth around which the community would gather, cook food, share stories, and forge the complex social bonds that are a hallmark of humanity. And they cooked. The act of cooking food, particularly meat and tough tubers, had profound implications. It made food easier to chew and digest, effectively externalizing the digestive process and freeing up energy. Some theorists argue this energy subsidy may have directly fueled the expansion of our energy-hungry brains. It also made food safer, killing parasites and pathogens. The hearth became the first kitchen, the center of domestic life. Their social world was undoubtedly complex. The hunting of large game evidenced by animal bones found with cut marks at their sites required coordination, communication, and planning. Bringing down a giant prehistoric deer or a wild horse was a dangerous, collaborative effort. This suggests a society capable of division of labor, of teaching complex skills to the young, and of caring for the injured and infirm. Evidence of traumatic injuries that had healed indicates that groups supported their members, allowing them to recover rather than abandoning them. This is a fundamental building block of empathy and community. They were also explorers. From their probable origins in East Africa, they radiated outwards. following river valleys and coastlines, adapting to a stunning array of environments. They pushed into the challenging seasonal landscapes of Europe and the woodlands of Asia. Their success was a testament to their behavioral flexibility. Their toolkit, their social structures, and their mastery of fire allowed them to become a pan-old world species. By 800,000 to 700,000 years ago, Homo heidelbergensis was, by any measure, a resounding success story. They were intelligent, technologically advanced, widespread, and socially sophisticated. They had overcome every challenge the Pleistocene world had thrown at them. Their future seemed assured, a gradual and inevitable expansion. The population, while never dense by modern standards, was likely growing, with groups scattered across thousands of miles. They were the masters of their world. But their world was about to change. The very climate that had nurtured their expansion was preparing to deliver a blow of such staggering severity that it would bring this successful, thriving species to its knees. The stage was set, the protagonists were in place, and the first act of the great drama was about to begin. The long, stable reign of Homo heidelbergensis was coming to an end, and a time of unprecedented trial was dawning. To understand the catastrophe that befell our ancestors, we must first understand the world they called home. We must step out of our modern climate, which has been remarkably stable for the last 12,000 years, and into a tumultuous, unpredictable, and often brutal epoch known as the Pleistocene, which spanned from about 2.6 million years ago to 11,700 years ago. This was not a static world. It was a world in constant, dramatic flux, a roller coaster of climatic extremes that set the stage for the greatest challenge humanity has ever faced. The defining characteristic of the Pleistocene was the Ice Age. But this was not a single, unbroken period of global freeze. Instead, think of it as a relentless, grinding pendulum swing. For tens of thousands of years, the planet would descend into a glacial period, or simply, a glacial. During these times, massive ice sheets, sometimes over a mile thick, would advance from the poles and from mountain ranges, covering vast swathes of North America, Northern Europe, and Asia. So much of the planet's water was locked up in these immense sheets of ice that global sea levels could drop by over 100 meters, exposing vast coastal plains, connecting continents, and creating land bridges like the one between Asia and North America. The world was colder, drier, and dustier. Deserts expanded. Lush forests retreated to tiny refugia, replaced by open grasslands and tundra that could support great herds of megafauna mammoths, woolly rhinos, steppe bison, which were harsh and unforgiving environments for a tropical primate. Then, the pendulum would swing back. These were the interglacial periods, brief, warm respites that punctuated the long glacial winters. During an interglacial like the one we are in now, the Holocene, the ice sheets would retreat, sea levels would rise, forests would reclaim the land, and the climate would become more moderate and hospitable. These periods were like a planetary springtime, but they were tragically short-lived, typically lasting only 10,000 to 15,000 years before the slow, inexorable creep of the ice began again. What drove this relentless pendulum? The answer lies in the heavens. The changes were triggered by subtle, cyclical variations in Earth's orbit and tilt, known as Milankovitch cycles. These cycles alter the amount and distribution of solar energy reaching our planet. A slight change in the eccentricity of Earth's orbit, a wobble in its tilt, or a shift in its precession. These astronomical nudges were the ultimate drivers of the ice ages, but they were only the trigger. The Earth's climate system itself would then amplify these small changes through feedback loops. For instance, as ice sheets grew, they reflected more of the sun's energy back into space, a process known as albedo, which caused further cooling and more ice growth, in a vicious cycle. Changes in ocean currents and greenhouse gas concentrations, like carbon dioxide and methane, acted as further amplifiers, turning a small nudge from the cosmos into a planetary-scale climate revolution. For early humans, this oscillating climate was the backdrop to their entire existence. Their survival depended on their ability to track and adapt to these profound changes. During warm, wet interglacials, populations could expand, moving into new territories as forests provided more resources. During glacials, they would be forced to contract, clinging to life in more favorable pockets of habitat, river valleys, coastal zones, or southern refugia that offered slightly more temperate conditions and reliable water sources. Their technology, their social networks, and their mobility were all tested by this endless cycle. But around 900,000 years ago, something in this rhythm changed. The pendulum didn't just swing, it appeared to get stuck. The Milankovitch cycles aligned in a particular way that pushed the global climate system past a tipping point. The evidence for this is locked away in ancient ice. Deep ice cores drilled from the glaciers of Greenland and Antarctica provide us with a breathtakingly detailed climate record. By analyzing the tiny bubbles of ancient air trapped in the ice and the isotopic composition of the water molecules themselves, scientists can reconstruct past temperatures and atmospheric conditions with astonishing precision. These ice cores tell a story of a dramatic shift. The climate cycles of the early Pleistocene, which had a rhythm of about 41,000 years, transitioned to the much longer, more severe 100,000-year cycles of the later Pleistocene, and the transition was not smooth. It was a period of intense instability. The world was plunging into a superglacial, a period of cold so intense and prolonged that it stands out even in the harsh context of the Ice Age. This was the world that Homo heidelbergensis faced. They had evolved during a somewhat milder phase, but now the rules of the game were changing radically. The lush, supportive environments that had allowed their population to grow and disperse were beginning to shrink, fragment, and vanish. Deserts expanded into grasslands. Forests died back. Water sources dried up. The once steaming herds of game animals, upon which they depended, migrated, shifted their ranges, or died out entirely. The corridors that had connected human populations were severed by ice, desert, or arid scrubland. Groups that had once been part of a larger metapopulation, exchanging genes, ideas, and resources, were suddenly cut off, isolated in shrinking islands of habitability in a vast, increasingly hostile world. The stage was now set for a catastrophe. The protagonists, Homo heidelbergensis, were successful and intelligent, but they were up against a force of nature that was global, inexorable, and utterly impersonal. The planetary climate machine was shifting into a new, more vicious gear, and it was about to test humanity's capacity for survival to its absolute limit. The great bottleneck was beginning. How can we possibly know about a population crash that occurred nearly 1 million years ago, a time that left behind only the scarcest of fossil remains? The people who lived through it are long dust, their cultures and languages utterly silent, and yet they left behind a message. It is not carved in stone or written on parchment. It is written in the most fundamental code of life itself, passed down through hundreds of thousands of generations, a ghost story whispered in the language of our genes. Unlocking this message is the work of population geneticists, and the story it tells is one of a desperate, narrow escape from oblivion. The evidence for the great bottleneck comes from two primary sources: the fossil record, which shows a startling absence, and the genomic record, which shows a profound signature of constriction. Let's begin with the stones and bones. The archaeological record for this specific period, between 900,000 and 800,000 years ago, is notoriously sparse. Across Africa and Eurasia, sites that were once occupied show gaps. Tool-making traditions, which had been steadily evolving, show signs of stagnation and regional isolation. The number of fossil specimens that can be confidently dated to this window is vanishingly small. For a long time, this could have been dismissed as a quirk of preservation, the simple misfortune that evidence from this time did not survive. But the silence was so widespread, so consistent across continents, that it began to look less like bad luck and more like a genuine emptiness. It was as if the vibrant human presence that had been there before had suddenly been dialed down to a faint whisper. But the most compelling and mathematically precise evidence comes from our DNA. Every human alive today carries within their cells a historical archive, library that details the population history of our species. Population genetics is the science that learns to read this library. It operates on a few key principles. One is that genetic diversity is a function of population size. A large, widespread population will accumulate a lot of genetic mutations over time, leading to high diversity. A small, isolated population has fewer individuals to contribute new mutations, and genetic drift, the random change in gene frequency, has a much stronger effect, wiping out diversity. The amount of genetic diversity in a modern population can therefore be used to infer the size of its ancestral populations. Another key principle is the concept of the coalescence. This is a statistical method that works backwards in time. It traces the lineages of different versions of Aegina alleles to find their most recent common ancestor. By analyzing the patterns of variation across the entire human genome, scientists can estimate when that common ancestor lived and how large the population was at that time. When geneticists applied these powerful tools to human DNA, they made a startling discovery. Studies of the genomes of modern human populations from all over the world consistently pointed to a dramatic event in our deep past. They revealed a severe reduction in population size that began around 930,000 years ago. The models showed that the effective population size, the number of breeding individuals, plummeted to approximately 1,280 and remained critically low for an astonishingly long period, over 100,000 years. This was not a brief, sharp event like a volcanic winter. This was a prolonged evolutionary stranglehold, a marathon of suffering that lasted for thousands of generations. This genetic bottleneck left an indelible mark, a scar on our genome that we can still detect. One of the most telling consequences is something known as the loss of heterozygosity. In a large population, you inherit two different versions of a gene, one from each parent, that are often quite distinct. This is healthy genetic diversity. In a tiny population, everyone is closely related. You are effectively inheriting two copies of a gene that are very similar, or even identical, because they trace back to a very recent common ancestor. The genome-wide signal of this is unmistakable. Furthermore, the bottleneck led to an accelerated rate of hitchhiking, where harmful mutations can become more common, because there simply aren't enough individuals for natural selection to effectively weed them out. The genetic evidence is so robust that it has been confirmed through multiple independent studies and methods. It tells a story not of a single, localized disaster, but of a species-wide constriction. The vibrant, widespread population of Homo heidelbergensis fragmented, shrank, and teetered on the edge. The fact that all modern humans from every continent carry this same genetic signature proves that we are all descended from that tiny group of survivors. Our low genetic diversity, compared to other great apes, like chimpanzees, is a lasting testament to this narration. We are a genetically homogeneous species, because we all spring from the same small root. So, the evidence is clear. The what is established, a catastrophic population collapse. The when is pinpointed, starting around 930,000 years ago and lasting for over 100 millennia. The who is identified, our ancestors, Homo heidelbergensis. But this leaves us with the most pressing and difficult question of all, the why. What could have been so terrible, so globally devastating, that it brought the most adaptable and intelligent species on the planet to the brink of extinction? The genetic ghost story has revealed the crime. Now we must search for the culprit. The genetic evidence has presented us with a stark fact. Humanity almost died out. The fossil record confirms a profound silence. Now, the investigation turns to motive and means. What force of nature could possibly have wreaked such havoc on a species as widespread, resourceful, and resilient as Homo heidelbergensis? The evidence, when pieced together from ancient ice deep-sea sediments and geological strata, points overwhelmingly to a single colossal suspect. A period of unprecedented climatic turmoil that plunged the world into a deep freeze and shattered the very ecosystems upon which our ancestors depended. This was not merely another swing of the Pleistocene pendulum. This was the transition to what scientists call the Middle Pleistocene transition, a period where the climate cycle shifted from a 41,000-year rhythm to a 100,000-year rhythm, and the glacial periods became profoundly more severe. The world didn't just get colder, it became unstable, unpredictable, and brutally arid. Let us break down the components of this climatic cataclysm that turned the planet into a death trap for its human inhabitants. First, and most significantly, was the intensification of the glacial periods. The ice sheets that advanced from the poles were larger and more extensive than ever before. But the problem wasn't just the ice itself. It was the climatic domino effect it triggered. The massive continental glaciers acted like a refrigerator for the entire planet, altering atmospheric circulation patterns. They sucked moisture out of the air, leading to plummeting rainfall levels far from the ice fronts. This caused megadroughts on a scale we can scarcely imagine. Across Africa and Eurasia, the evidence is written in the geology. Ancient lakebeds that shrank to tiny saline puddles or vanished entirely. River systems that ceased to flow their valleys, turning to dust. And vast expanses of desert that expanded, swallowing up savannas and woodlands. For a species reliant on steady water sources, predictable animal migrations, and plant resources, this desiccation was catastrophic. The once reliable watering holes dried up. The great herds of grazing animals that provided crucial fat and protein either died out or were forced to migrate to ever-shrinking patches of viable habitat. The edible plants, nuts, and tubers became scarce. The map of human habitability was being ruthlessly redrawn, with fertile areas transforming into uninhabitable wastelands. Populations found themselves stranded in ecological islands, cut off from each other by barriers of desert and arid scrubland. This fragmentation was a death sentence in itself, as isolated groups became vulnerable to inbreeding, local disasters, and slow attrition. Second, this period was marked by extreme climate volatility. The ice core records show not a smooth descent into cold, but a violent roller coaster of sharp, dramatic swings. There would be short, slightly warmer periods, followed by precipitous drops into extreme cold. This volatility would have been even more challenging to adapt to than a steadily cold climate. How do you plan your hunting strategies, your seasonal migrations, or your resource gathering when the rules of the game change every few generations? A behavior that was successful in one decade could lead to starvation in the next, as the environment shifted beneath their feet. This kind of instability prevents the long-term cultural adaptation and accumulation of knowledge that is key to human success. It's a relentless game of climatic whiplash. Third, we must consider the direct physiological stress. Homo heidelbergensis was a tropical primate. While they had mastered fire and could create clothing from animal hides, a world plunged into a deep glacial period presented existential challenges. Simply staying warm required vastly more calories. Food sources were already becoming scarcer due to the drought, and now their bodies needed more fuel just to maintain basic metabolism. The cold, dry air increased the risk of respiratory illnesses. For vulnerable populations, the very young, the elderly, pregnant women, these conditions would have been lethal. Infant mortality would have skyrocketed. Fertility rates would have plummeted, as the female body, under severe nutritional and physical stress, will shut down the reproductive system to ensure its own survival. The combined effect of these factors, extreme aridity, ecosystem collapse, habitat fragmentation, climatic instability, and physiological stress, creates a perfect storm of extinction pressures. It wasn't one bad winter. It was a 100-millennium-long siege. The population didn't crash overnight. It was a slow, grinding process of erosion. Group by group, clan by clan, they were worn down. A drought here causes a local extinction. A particularly harsh winter there wipes out another band. The connections between groups are severed, and the genetic and cultural exchange that keeps a species vibrant ceases. The number of breeding individuals shrinks, and the downward spiral accelerates. This climatic hypothesis is the most parsimonious explanation. It is global in scale. It aligns perfectly with the timing of the genetic bottleneck, and it provides a mechanism that fits the evidence. The world itself became the antagonist, and the struggle for survival was a battle against a changing planet. However, a crime of this magnitude often has more than one culprit, while climate was the overarching driver. Some scientists have proposed that other factors may have acted as accomplices, delivering the final blow to a population already on its knees. Our investigation must now turn to these other potential suspects. While the case for a climatic cataclysm as the primary driver of the population bottleneck is overwhelming, a detective must always explore all possibilities. Could other forces have contributed to the downfall of early humanity? Could a population already reeling from climate change have been pushed over the edge by a secondary, catastrophic event? Scientists have proposed several intriguing accomplices to the crime. Factors that may not have caused the bottleneck alone, but could have exacerbated an already desperate situation, sealing the fate of many groups and deepening the crisis for the survivors. The first and most dramatic of these potential accomplices is a colossal volcanic eruption. We are not talking about a typical volcanic event, even one as powerful as Krakatoa or Mount St. Helens. We are talking about a supervolcanic eruption event of such staggering magnitude that it can alter the climate of the entire planet for years, even decades. When a supervolcano erupts, it does not simply blow its top. It collapses in on itself, ejecting thousands of cubic kilometers of ash, rock, and, most importantly, sulfur aerosols high into the stratosphere. These sulfur aerosols form a global haze, that reflects sunlight back into space, causing a rapid and severe drop in global temperatures, a phenomenon known as a volcanic winter. This would be a sudden, shocking blow on top of an already deteriorating glacial climate. Imagine a world already growing colder and drier, suddenly plunged into a years-long twilight. Summers would fail. Plants would wither from the lack of sunlight and frost. Animal populations would collapse. For humans reliant on hunting and gathering, it would be an immediate and absolute catastrophe. A volcanic winter lasting just a few years could wipe out countless groups who were already living on the ecological edge. The geological record does show evidence of massive volcanic eruptions around this general time frame. While pinpointing an exact eruption to the precise start of the bottleneck is incredibly difficult, the tantalizing possibility remains. A supereruption could have been the proverbial straw that broke the camel's back, triggering the final fatal downward spiral for a globally stressed population. A second, more subtle accomplice could have been disease. The concept of a pandemic affecting early human populations is difficult to prove, but it is biologically plausible. The fragmentation of habitat caused by the expanding deserts and arid zones would have isolated groups, allowing novel pathogens to evolve in these isolated pockets. Furthermore, the changing climate itself can alter the range of disease vectors, such as insects or parasites, exposing human populations to new illnesses. In a large, interconnected population, a novel disease might burn through a region, but leave enough immune survivors to recover. But in a world where groups were already small, isolated, and under severe nutritional stress, their immune systems would have been compromised. A novel virus or a particularly virulent strain of bacteria could have ravaged a band, leaving no survivors. This could have happened repeatedly across the landscape, silently wiping out groups that had managed to hang on through the climatic hardships. Disease is an invisible killer in the archaeological record, but its potential role in a demographic collapse of this kind cannot be entirely dismissed. A third potential factor is interspecies competition and conflict. Homo heidelbergensis was not alone in the world. They shared their environment with other formidable predators: cave lions, giant hyenas, saber-toothed cats. As resources became scarcer, competition with these carnivores would have intensified. A successful hunt yielding a large carcass would have attracted not just other humans, but dangerous competitors capable of driving them from their hard-won meal, or even preying upon them directly. The risk of predation likely increased dramatically for small, vulnerable bands of humans. Furthermore, there is the possibility of conflict with other hominins. While Homo heidelbergensis was the most advanced human species of its time in Africa and Europe, other archaic groups may have existed in Asia. As the climate worsened and habitable land shrunk, different human groups would have been forced into closer proximity around dwindling resources like waterholes and fertile valleys. This could have led to violent conflict. In a world of scarcity, other humans are not just neighbors, they are competitors for the very means of survival. Skirmishes and raids over resources could have further reduced already precarious population numbers. It is crucial to understand that these factors are not mutually exclusive. In fact, they likely worked in a devastating synergy. The primary driver was the climatic shift, which created a world of scarcity and fragmentation. This stressed the human population, making it vulnerable. A volcanic winter could then deliver a sudden, devastating shock. Novel diseases could continue to spread through malnourished and isolated groups. Competition with predators and other humans would have intensified over the scraps that remained. This is the concept of a synergistic extinction cascade. One major stressor weakens a population, making it susceptible to a whole suite of other threats that it could otherwise have weathered. The population wasn't just facing a changing climate, it was facing a perfect storm of ecological disasters. The resilience of Homo heidelbergensis was being tested on every possible front. For the vast majority of them, the test was too great. They vanished, leaving behind only the faintest of traces. But for one small group, or perhaps a few interconnected bands, something allowed them to hold on. They found a refuge, a place where the rules of the new, harsh world were slightly less cruel, and they clung to life with a tenacity that would define the future of our entire species. Their story of survival is the next chapter in this incredible saga. The genetic evidence paints a picture of a species reduced to a threadbare community of little more than 1,000 breeding individuals. The climatic and ecological evidence reveals a world turning hostile, with once fertile landscapes transforming into arid, unforgiving deserts. This leads to one of the most compelling questions of the entire bottleneck mystery. Where did they go? In a world that had become so largely uninhabitable, where was the refuge? What kind of place could have sheltered this tiny band of survivors, providing them with the resources to endure not for a few years, but for over 100 millennia? The search for this refuge is a grand scientific puzzle. There is no smoking gun location with a plaque that reads "Humanity saved here." Instead, scientists use deductive reasoning, combining clues from genetics, paleoclimatology, and archaeology to narrow down the possibilities. The refuge would have needed to possess a very specific set of characteristics to act as a lifeboat for a species on the brink. First and foremost, it required stability. In a world gripped by climatic whiplash, this sanctuary would have had to offer relative environmental consistency. This likely meant a coastal location. Oceanic environments are buffered against the extreme temperature swings that ravage the interiors of continents. The sea maintains a more stable temperature, and coastal regions often benefit from reliable fog and moisture, even when inland areas are parched by drought. Shellfish, in particular, are a nutritious, abundant, and easily harvested resource that can sustain a population through hard times. Second, it needed water. While the interiors of continents were drying up, certain regions would have maintained hydrological stability. This could include major river deltas. The confluence of a great river and the ocean creates a rich, complex ecosystem teeming with life, from fish and waterfowl to lush vegetation. Spring-fed oases. In certain geological settings, underground aquifers could have fed permanent springs, creating isolated pockets of green in a vast brown landscape. Mountainous regions. While high altitudes were getting colder, certain mountain ranges, especially those near coasts, can create their own weather patterns through orographic rainfall, catching moisture from the air and providing a steady flow of water to valleys below. Third, the refuge needed topographic complexity. A flat, uniform landscape offers no escape from changing conditions. A rugged, varied landscape with deep valleys, high plateaus, and complex coastlines creates what biologists call microfugia. South-facing slopes capture more sun. Deep river canyons offer shelter from wind and retain moisture. Caves provide permanent shelter from the elements. This complex topography allows a small group to move vertically and horizontally within a small area to find the most favorable microclimates as the seasons change or the climate worsens. So, where on the map does this point us? Genetic studies suggest that the population that gave rise to all modern humans was located in Africa. Therefore, the search is focused on the African continent. Two primary candidates have emerged, each with compelling arguments. The first is Southern Africa. This region, particularly the area around what is now South Africa, is dotted with archaeological sites from this general era. It's a region of incredible topographic diversity, with mountains, coastal plains, and sheltered valleys. Its southern latitude might have offered some buffer against the extreme aridity affecting the north. The rich coastline of the Cape would have provided a stable marine larder. Some genetic models also point to a southern origin for the modern human lineage. The second, and perhaps more favored, candidate is East Africa. This is the traditional cradle of humankind, home to the Great Rift Valley. The Rift Valley is a textbook example of topographic complexity. Its deep gorges, high escarpments, and series of lakes would have created countless microfugia. Crucially, it is also a volcanic region. Volcanic activity can create highly fertile soils and, just as importantly, geothermal hot springs. In a world plunging into cold, a region with natural hot water sources would have been an unimaginably valuable sanctuary, providing warmth, fresh water from steam condensation, and a place where plants could thrive. The series of large lakes in the East African Rift, such as Lake Malawi and Lake Tanganyika, which are ancient and deep, would have acted as massive reservoirs, maintaining humidity and supporting life even during megadroughts. Life in this refuge would have been incredibly difficult, but stable enough to permit survival. The group would have been small and intensely social. Every individual's life would have been of paramount importance, knowledge of where to find water in the dry season, which plants were edible, how to track the few remaining game animals, how to tend the life-giving firewood have been the community's most precious commodity, passed down with utmost care from elder to youth. They were trapped in their sanctuary, but they were alive. For over 100,000 years, this was the entire world for humanity. Their story had narrowed to a single, fragile thread. But within that thread, the genetic diversity that would eventually seed the entire planet was preserved. They were waiting, and then, slowly, the world began to change again. The Ice Age's grip began to loosen, and the doors of their refuge began to creak open. The long isolation was about to end, and the next great adventure of the human species, the great reconquest of the world, was about to begin. Their endurance through the bottleneck had forged them into something new, a lineage with a destiny that would eventually touch every corner of the globe. For over 100,000 years, the small band of survivors existed in their refuge, living a life of profound isolation. This was not a mere pause in the human story. It was a transformative crucible. 100 millennia is an almost incomprehensible stretch of time. Over 3,000 generations of humans were born, lived, and died within the confines of this limited world. This prolonged period of extremely low population size was not just a demographic event. It was an evolutionary pressure cooker that fundamentally shaped the genetic and perhaps even cognitive future of our lineage. Within this tiny population, the normal rules of evolution changed dramatically. Genetic drift, the random fluctuation of gene frequencies, became the dominant evolutionary force, far surpassing natural selection. In a large population, a new, beneficial mutation can spread, and a harmful one can be weeded out. But in a group of only 1,300, chance reigns supreme. A hunter of great skill might be killed in a random accident before passing on his genes. A particularly harsh season might randomly wipe out several families, and with them, unique genetic variants they carried. This random winnowing of genetic diversity was relentless. Many ancient genetic lineages that had been carried by Homo heidelbergensis for hundreds of thousands of years simply vanished, lost forever by the cruel lottery of chance. This is why the bottleneck left such a stark, universal scar on our genome. It was a genetic reset. This process also led to what geneticists call a selective sweep. When a population is this small, a genetic mutation that is beneficial can spread to fixation, meaning it becomes universal in the population incredibly quickly. There is simply less genetic static for it to compete against. It is highly likely that during this long isolation, our ancestors acquired several key mutations that provided crucial adaptations for survival in their challenging world. Perhaps it was a more efficient metabolism for extracting nutrients from scarce food, or an enhanced immune system to fight off novel pathogens, or even changes in social cognition that strengthened group bonds and cooperation under extreme stress. The bottleneck wasn't just a period of loss, it was also a period of rapid, focused genetic innovation that equipped the survivors for the world they were in. This extended isolation also had profound cultural implications. With such a small group, cultural practices would have become highly uniform and deeply ingrained. The knowledge required for survival, the intricate understanding of every plant, animal, water source, and seasonal change within their refuge would have become a sacred law. Language, likely already complex before the bottleneck, would have been refined and developed. In a world where every individual was precious and group cohesion was a matter of life and death, the ability to communicate complex ideas, to tell stories that reinforced social bonds, to plan and coordinate with absolute precision, would have been paramount. It is possible that the social and cognitive tools that later enabled the explosive expansion of Homo sapiens were forged in the intense fires of this long isolation. Adversity bred a new level of cooperation and cultural sophistication. Meanwhile, outside the refuge, the world was changing. The other branches of the human family that had been cut off from this African group faced their own fates. The populations of Homo heidelbergensis that had migrated into Eurasia hundreds of thousands of years earlier were also isolated by the same climatic devastation. They were trapped in their own refugia, likely in parts of southern Europe and Western Asia, and in their own crucibles of isolation, they were evolving down separate paths, cut off from the African source population for over 100,000 years, and subjected to their own unique pressures of genetic drift and adaptation to the colder Eurasian climates. They were becoming distinct species, From these isolated Eurasian populations would eventually emerge the Neanderthals, perfectly adapted to the glacial environments of Europe, and the Denisovans, who spread across Asia. The Great Bottleneck Event, therefore, was not just a crisis for our direct ancestors. It was the evolutionary fork in the road that split the human family tree into separate, distinct branches. The Africans in their refuge and the Eurasians in theirs were no longer part of the same genetic stream. They were becoming cousins, destined to meet again hundreds of thousands of years later under vastly different circumstances. Then, finally, the climate began to shift. The immense glacial period that had held the planet in its grip for so long began to wane. The ice sheets started their slow, inexorable retreat. Rainfall patterns shifted, and the deserts that had acted as impassable barriers began to bloom once more. Corridors of habitability reopened, connecting the refuge to the wider world. The long quarantine was lifting. The small, hardened, and genetically unique population that emerged from the refuge was no longer quite Homo heidelbergensis. They were something new, a lineage that had been reshaped by its ordeal. They are what scientists call the Middle Pleistocene stem lineage, the direct ancestors of Homo sapiens. They carried with them the genetic scars of their near extinction, the adaptive innovations forged in isolation, and a sophisticated cultural toolkit honed by necessity. They stepped out of their sanctuary into a world ripe for recolonization. They were few in number, but they were resilient, adaptable, and carried within them the seed of a future that would eventually encompass the entire globe. The age of recovery and expansion was about to begin. The small band that emerged from their long isolation did not simply resume the old ways of Homo heidelbergensis. They were a new people, shaped and tempered by their ordeal. The genetic bottleneck was not merely a destructive event that stripped away diversity. It was a creative, albeit brutal, evolutionary forge. The pressures of those 100,000 years sculpted the very essence of our species, leaving a legacy that is embedded in our biology, our society, and our paradoxical nature. The survivors did not just endure, they were transformed, and in their transformation, they laid the foundation for everything that was to come. One of the most profound legacies is our startling genetic uniformity. Compared to our closest primate relatives, like chimpanzees, whose populations across Africa exhibit far greater genetic diversity, all humans on Earth are remarkably similar. Two chimpanzees from opposite sides of a jungle can be more genetically distinct from each other than any two humans chosen from anywhere on the planet. This is the direct, undeniable signature of the bottleneck. We are all so similar because we are all descended from that tiny group of survivors. Our family tree is not a broad, bushy oak with many ancient branches. It is a slender sapling that nearly died, with all of its modern branches growing from a single, narrow trunk. This genetic bottleneck scar is the reason why, despite our superficial external differences, at a genetic level, we are one family. This event also accelerated our evolution. The same genetic drift that wiped out so much diversity also allowed new beneficial mutations to spread rapidly through the small population. It is during this period that scientists believe several key genes crucial to the modern human experience may have been selected for. These include genes related to brain development and neural connectivity, potentially supercharging our capacity for complex language, abstract thought, and symbolic reasoning. The intense social pressures of living in a small, interdependent group would have favored individuals who were better at communicating, cooperating, and understanding the intentions of others, a theory known as the social brain hypothesis. The bottleneck, therefore, may have been the catalyst for the cognitive revolution that later defined Homo sapiens. Furthermore, our very social nature may be a product of this in a world where the margin for error was zero. Cooperation wasn't just a virtue. It was the only strategy for survival. The groups that thrived were those that could most effectively share resources, care for their sick and injured, and work together for the common good. This forged an ultra-social instinct deep within our psyche. The need to belong to a group, to seek its approval, and to contribute to its welfare became hardwired. This is the bedrock of human culture, morality, and our incredible capacity for altruism. But this same legacy has a darker side, an innate wariness of outsiders, a tendency towards tribalism. If your small group was all that stood between life and death, strangers were not a curiosity. They were a potential threat to your fragile resources. This deep-seated duality between profound cooperation within the group, and suspicion of those outside. It is a paradox that has shaped human history ever since. The bottleneck also set the stage for the next act of the human drama, the Great Diaspora. When the climate finally improved and the population began to expand, it did so from a unified genetic and cultural core. They were not multiple, disparate groups rediscovering each other. They were one people, radiating outward from a point of origin, carrying a shared biological and cultural toolkit. This initial cohesion is what allowed for the rapid and cohesive spread of new technologies and cultural innovations that characterize the archaeological record after the bottleneck. Finally, the legacy of the bottleneck is a lesson in fragility and resilience. It is a humbling reminder that our species' dominance of the planet is not preordained. It is the result of a thread of chance, a story of luck and tenacity stretched taut across 1,000,000 years. We are here not because we were inevitable, but because our ancestors were tough, adaptable, and fortunate enough to find a sanctuary in a world that had turned against them. This deep history lives within us still. It is in our genes, in our social bonds, and in our shared story. The echo of that ancient population collapse is a permanent part of us, a whisper from a time when the world was almost emptied of human voices. It is a story that belongs to every single person alive today, for we are all, every one of us, children of the survivors. The story of the Great Bottleneck is not merely a fascinating chapter from a dusty history book. It is a living narrative whose echoes resonate powerfully in the modern world. Understanding this near-extinction event is more than an academic exercise. It provides a profound context for who we are as a species today, how we interact with each other and the planet, and the challenges we face in the future. The legacy of those 1,280 survivors is written into our biology, our psychology, and our global society, and recognizing it can help us navigate the complexities of the 21st century. First, the bottleneck offers a powerful, unifying perspective on human identity. In a world often divided by nationality, ethnicity, religion, and culture, the genetic evidence presents an irrefutable truth. We are all astonishingly closely related. The superficial differences that we sometimes allow to define and divide us are just that, superficial. Beneath the surface, we share a common ancestry that is recent and dramatic. Every human conflict, every act of discrimination or prejudice, is fundamentally a conflict between cousins, between members of the same incredibly small and recently endangered family. This knowledge does not erase our cultural diversity, which is a beautiful product of our later adaptations and migrations, but it places it on a foundation of deep, fundamental unity. We are one species, with one origin story of resilience. Second, this history provides crucial insight into our relationship with the natural world. The bottleneck was caused by dramatic climate change, a shift in the Earth's systems that was beyond our ancestors' control. Today, we are facing another period of profound climatic shift, but this one is of our own making. The story of the bottleneck serves as a stark warning of how vulnerable our species can be to environmental change. It reminds us that our civilization, for all its technological marvels, is not immune to the forces of nature. We are still the same species that was nearly wiped out by a changing climate. This ancient memory should instill in us a deep sense of urgency and responsibility to steward our planet's ecosystems, to preserve the stability that has allowed us to thrive for the last 12,000 years. The lesson from our ancestors is that environmental stability is not a given. It is the essential prerequisite for human flourishing. Third, the bottleneck helps explain certain modern genetic challenges. Our lack of genetic diversity has a downside. Recessive genetic disorders are more common in our species, because the small founding population meant that harmful recessive genes had a higher chance of being passed on and paired up in later generations. Furthermore, our rapid expansion across the globe led to adaptations to local environments, such as skin pigmentation or adaptations to high altitude. But at a genomic level, we remain a homogeneous species. Understanding this genetic history is crucial for modern medicine. From tracing the origins of hereditary diseases to understanding population-specific responses to pharmaceuticals. Finally, the story is a timeless testament to human resilience. It is the ultimate underdog story. Against impossible odds, a group of a few hundred people endured for over 100,000 years. They passed down the ember of knowledge, culture, and language, protecting it through the long night. They are the reason we are here today, to ponder the stars, create art, and seek meaning. This narrative should fill us with a profound sense of gratitude and awe for the fortitude of our ancestors. It is a source of strength and hope. If they could persevere through such darkness with nothing but simple tools, social bonds, and sheer will, then what can we achieve today? The question, why did 99% of early humans vanish, leads us on a journey to the very edge of extinction, but it ultimately brings us back to ourselves. It reveals our shared fragility and our incredible capacity for endurance. It reminds us that we are the descendants of survivors. Their strength is our inheritance. Their story is a humbling and empowering reminder that we are all connected to a deep past, and the choices we make today will echo, just as powerfully, far into the future. The flame they guarded so carefully for millennia is now in our hands. It is up to us to ensure it continues to burn brightly. Our journey, which began with a staggering statistic, the vanishing of 99% of early humans, now reaches its end. We have traveled back nearly 1 million years to a world of ice and dust, and met our resilient ancestors. Homo Heidelbergen says, we have explored the evidence, pieced together from the silent language of genetics and the patient testimony of ancient ice and stone, that reveals a species brought to the brink of annihilation. We have investigated the prime suspected climatic cataclysm of unprecedented severity and its potential accomplices, from supervolcanoes to disease. We have searched for their sanctuary, the refuge that served as a lifeboat for over 100 millennia, and witnessed how that long isolation forged them into something new. And we have traced the enduring legacy of this bottleneck, a legacy written in our genes, our minds, and our interconnected world. The story of the Great Bottleneck is, in its essence, a story of fragility and resilience. It shatters the illusion of human inevitability. We are not the preordained masters of the planet, but the beneficiaries of incredible fortune and tenacity. Our existence today hangs by a thread that was once stretched almost to breaking. For more than 100,000 years, the entire future of the human species, every song, every story, every invention, every love was entrusted to a single, small community, fighting for survival each day. Yet, it is also the most profound story of hope ever told. Against impossible odds, they endured, they adapted, they cooperated, they passed the ember of consciousness from one generation to the next, protecting it through the long glacial night. Their survival is a testament to the power of community, of knowledge, and of the indomitable will to live. The question, why did 99% of early humans vanish, has been answered not with a single cause, but with a complex tapestry of environmental disaster and evolutionary chance. But the more important question, the one their lives answer, is, how did the 1% survive? They survived through ingenuity, through social bonds, and through an unwavering resilience that is humanity's greatest inheritance. We are the children of that 1%. Their story is our story. Their survival is our origin, and their legacy is a reminder that we are all, every one of us, connected by a thread of survival that is both terrifyingly thin and miraculously strong. It is a thread we must cherish, protect, and pass on, just as they did. Our exploration, ignited by the haunting question of why 99% of early humans vanished, now draws to a close. We have traversed the immense expanse of deep time, returning to an epoch where the very world itself seemed to turn against humanity. We stood alongside Homo Heidelbergenses, our robust and intelligent ancestors. As they faced a climatic cataclysm unlike any other, we deciphered the silent, elegant language of genetics, uncovering the stark evidence of a population collapse etched into the very core of our being. We followed the scientific detective work that pieced together this mystery from ancient ice core, geological strata, and the scarce but telling archaeological record. We considered the prime suspector, devastating superglacial that plunged the planet into arid, volatile cold and its potential accomplices. From earth-shattering supervolcanoes to novel diseases running rampant through fragmented and starving populations, we sought out their likely refuge, a life-sustaining sanctuary of topographic complexity and ecological stability, where a tiny band clung to existence for over 1,000 centuries, and we witnessed how this long, profound isolation acted as an evolutionary crucible, forging a new human lineage and setting the stage for the future emergence of our own species, Homo sapiens, and our distant cousins, the Neanderthals and Denisovans. This narrative is, at its heart, the ultimate story of fragility. It is a humbling corrective to the notion of human exceptionalism and inevitability. We are not the preordained masters of the globe, but the fortunate descendants of a group that stared into the abyss of extinction and, through a combination of sheer tenacity, behavioral flexibility, and plain luck, managed to step back. For more than 100,000 years, a span of time that dwarfs all of recorded history, the entire genetic and cultural future of humanity was entrusted to a community small enough to fit in a modest village. Every achievement of our civilization, every work of art, every scientific discovery, every act of love and kindness exists because they endured. Our existence today hangs by a thread that was once stretched to its absolute limit, a thread that is both terrifyingly thin and miraculously strong. Yet, this is simultaneously the most profound story of resilience and hope ever told. Against a backdrop of unimaginable hardship, they persevered. They mastered their limited environment with intimate precision. They honed their social bonds into a lifeline, understanding that cooperation was not merely beneficial, but essential for survival. They nurtured the embers of technology, language, and culture, protecting this precious knowledge through the long glacial night and passing it faithfully from one generation to the next. Their survival is a powerful testament to the human spirit's capacity to endure, adapt, and overcome. It speaks to the incredible power of community, shared purpose, and the unwavering will to live. The central question, why did they vanish, has been answered not with a single, simple cause, but with a complex interplay of global environmental shifts and evolutionary pressures. The how, however, how the 1% survived is where we find the true meaning. They survived through ingenuity, through an unparalleled ability to cooperate, and through a resilience that is the deepest and most fundamental part of our shared inheritance. We are the children of that 1%. This is not a metaphor. It is a genetic, historical, and spiritual fact. Their story is our common origin story. The echoes of their struggle resonate within us still, in our startling genetic uniformity, in our profound social needs and capacities, and in our paradoxical tendencies toward both incredible altruism and deep-seated tribalism. The bottleneck was not just an event that happened to us long ago. It was an event that actively sculpted who we are. Therefore, this ancient history is not a remote abstraction. It carries urgent lessons for our modern world. It reminds us of our profound and inescapable unity. The superficial differences we sometimes allow to divide us are meaningless against the backdrop of our shared journey from the brink. We are one family, one species, with one origin story of survival against all odds. Furthermore, it serves as a stark warning from our own past. Our ancestors were brought to the edge of extinction by dramatic climate change, a force beyond their control. Today, we are unleashing a similarly dramatic climatic shift through our own actions. Their story reminds us that we are not separate from nature. We are subject to its laws and vulnerable to its changes. The stability of our environment is the foundation upon which our civilization is built, and it is a foundation we must protect with unwavering commitment. Finally, this story is a wellspring of strength. If our ancestors could persevere through such darkness with nothing but simple tools, social bonds, and fierce determination, then what can we achieve today? Their legacy is a gift of resilience, a reminder that humanity possesses an incredible capacity to face immense challenges and emerge transformed. The thread of survival they guarded so fiercely for millennia now passes through our hands. It connects us to that deep past and stretches forward into the future we are now shaping. Their story bestows upon us a profound responsibility to honor their struggle by being wise stewards of each other and of the planet that is our only home. The flame of consciousness they kept alive against all odds now burns brightly in us. It is our privilege and our duty to ensure it continues to light the way forward.